Hi, hello everyone, this is Matheus from MiningMath, and on today's video I'm going to bring a bit of a few novelties about MiningMath, the MiningMath SimSCAD, and some change in the brand, in the positioning, etc. So basically, SimSCAD is being gradually rebranded to MiningMath, so the same name of the company. I'm here navigating in MiningMath's knowledge base. And here you might find more novelties and more information about this change. You can go here, trending topics, MiningMath versions, and understand more of the change in our portfolio of products and services. So SimSCAD Pit Optimizer and SimSCAD Direct Block Scheduler are being replaced for 3 different versions called MiningMath Demo, MiningMath Lite, MiningMath Full. Okay, MiningMath Full is equivalent to SimSCAD Direct Block Scheduler Full. MiningMath Demo is a demonstration version for learning purposes and also for demonstration concepts and proof of concepts to clients as well. And MiningMath Lite is an intermediary module which is more complete than what was previously called the SimSCAD Pit Optimizer. It will already give you a given sequence of extraction, but with fewer constraints available in comparison with MiningMath Full. Okay, so that's the context. Here we have all information about this transition from SimSCAD to MiningMath, because we're in a sense recognizing broader scope we can cover with our technology. Okay, so that's the main point I would like to share. I will bring these links in the description below. And well, here the main point is to navigate on the interface. Here we are starting to deliver a few scenarios pre-configured, so you can easily follow through with a sample data set, etc. And basically navigate and understand the possibilities on practice with MiningMath's optimizer, and also before committing to reading lots of materials, you can see the facts in practice. We believe being pragmatic in this regard is pretty much welcome to understand and move forward faster. Okay, so that's our suggestion, to play a little bit with these scenarios to understand constraints, etc., etc. So here, as you can see on the interface, we have pretty much of a straightforward process over here. I'm skipping the importation and dataset formatting just to be more direct with the main part of assessing multiple possibilities of the strategic scenarios for high-level decision making, right? So as you can see, we have a pretty much of a straightforward interface over here, and in which we can cover or navigate through different sorts of constraints. Okay, and we could even go straight to the overview panel to see all the constraints that have been configured, or we can gradually navigate through different tabs. Okay. So here, basically we have the densities. We can select the density field. We can attribute the full value for blocks missing this information. We have a discount rate, which is part of the optimization, and that, I mean, the part of the evaluation of the optimal decision on if a block should be mined, when it should be mined, what should be the ideal destination for that, etc., etc. So this is something that is available in the interface, and it's also part of the trade-off analysis internal in the algorithm. Okay, that's a pretty much of an important point to mention. Here we have the possibility of selecting slope angles, so columns with slope angles definitions. We also can have a default value. Over here, we're not using the field available in the model, which is defined block by block. It could be defined, for example, these slopes could be defined based on block by block, but based on lithotypes, or it could be defined based on mining sector, etc., etc. And you could, in fact, have multiple columns of different slope definitions, techniques, etc., to just select the one you want to work with later on the interfaces I'm doing right now. So here we have the possibility of including stockpiling costs, etc. The fixed mining cost, this is part of the economic value. So this value is not being counted twice. It's here just for or MiningMath, sorry, to understand what value has been used before inside the block model, and to do let's say reverse engineering to properly calculate the net present value for stocked blocks. Okay, so the rehandling cost is something that is not present in the economic formulation, in the economic values for each block, but it's an additional cost you must insert over here because it will be related to reclaiming a block from the stockpile. Okay, here we have the destination tabs where we can add multiple processing streams, multiple waste dumps, etc. The recoveries here are also part of the economic values defined before, prior to importation, and they are being informed over here just for a matter of the software recognizing the value used before and to generate the charts properly. Okay, the report charts properly. Here you can see you have the possibility of selecting whatever economic function or benefit function for your processing stream. The same for waste dump. In this case, I have just one assumption for waste. But for example, for processing streams, I wanted to consider different selling prices for copper, increasing 5-10%, decreasing in the same amount. So I created multiple columns prior to importation, and this is pretty much of some tips and tricks to facilitate this workflow and create as much columns as needed prior to importation, so you can just create your scenario and select the function you are willing to work with for each scenario. Okay, here I have the stockpile limit, which is a cumulative limit. The production tab brings me the possibility for defining for different period range the productions for each destination and for the total destination, for the total material mobilized or moved into each period. So you can add range over here, configure then whatever is what you're looking for. And we have the geometric parameters. Mining width is, bottom width is, vertical rate of advancement, or also known as sinking rate, and also the surface mining limits, which are forced mining possibilities to, let's say, to deplete a certain area of the deposit into a specified time frame. So whenever you add those surfaces, which are in a sense defined as a grid of points, you will be working with these paired range. So all you need to do is to add, let's say, an interval, and let's say for here, or let's go to the overview tab. So I have from period 1 to period 1, I could use a given surface over here and say up to period 1, which could be a year, a month, a semester, etc. I want to deplete a certain area. So for these surface constraints, always consider that these constraints will be applied until these specified time frame. Okay, so if you want to restrict, let's say you are working with restrict mining considering the mining rights. Okay, so the mining rights, instead of applying here and here, you just need to apply here, because it will be valid for the entire life of mine, because it's more related to the final period. Okay, because if it's limited unto the final period of the life of mine, it will be necessarily applied to the periods before that. Okay, so that's just a subtle information for you to work with surface mining limits. So the force mining represents, in a sense, the minimum depth you should achieve within a given time frame, okay? While the restricted mining represents the maximum depth you should achieve within a given time frame. So minimum and maximum depths you should achieve. Okay, so getting back to here, geometric constraints here more related to certain operational aspects, at least minimal operational aspects you might need. Sometimes or often we recommend you don't use these for the first cases, because these constraints demand a sort of complexity to convert continuous variables into nonlinear and integers. So there's a heuristic over here, and sometimes by not using these constraints, these results could be refined later on with the input from an engineer or a mine planner, etc., etc. Okay, so this is just a suggestion, of course, but you can move the way you think it's more proper. So something we have changed on the interface was the blending constraint. So now it's called average, okay? Because average brings the sense that you can work with any property and control them by average. Right now, these averages are calculated and being weighted based on blocks tonnage, okay? And they are for this very moment, they are attached to units related to grade, but I wanted to ensure this constraint is not limited to controlling grades. You could control whatever variable you want to control based on average values. So minimums and maximums, here we have copper, gold, and we can make this control for how many destinations and how many paired ranges you have, okay? And also for multiple elements as well. Okay, the sum was previously called other constraints, and it has changed to make it similarly more intuitive to understand. So whatever parameter or variable you have modeled inside your block model or data set, whatever parameter you want to control, considering the sum of this property, like processing hours, which is the case over here, you can control them based on minimums and maximums as well. So this is not a filter, like if in this filter, then use this value, or if not in this filter, use this value. So something you could do, for example, would be controlling material type. You could say, well, I have material types A, B, and C, and if a block is of material type A, the column material type A will have a tonnage value for this block, for example. And so I could control the proportions of different rock types, or even being able to report inferred, indicated, and measured resources. Okay, so whatever parameter you're able to say, well, this block has these properties, and I want to considering these, I'm able to calculate a given or to model a given property. Okay, like processing hours. How much hours this block will demand from my mill, for example. And then on the interface, you will be able to constrain the processing hours available for the mill. Okay, so pretty much of simple examples over here. You have plenty of scenarios. We have a scenario assuming an increase in 10% in the price of copper selling price, price decrease as well in 10%, a prediction ramp up, etc., etc. So navigate through these different scenarios, test, play around with them, and that's our suggestion for starting to understand the possibilities with MiningMath, and how to better understand how you can build your decision tree, and also the effects of these changes, because the sequence is freely available to change completely depending on the set of constraints defined for each scenario and always with the goal of optimizing or maximizing the net present value. Okay, so that's the general message for this video. I'm going to record another one exemplifying this decision tree, but please go ahead and test by yourself so you can use a hands-on approach to better understand the possibilities and also bring more ideas. We can discuss this in our support service, etc., etc. So please, if you have any questions, don't forget to comment below or contact support@miningmath.com. Thank you very much, and see you